Alright, so for this week's lesson, we'll be looking at the binomial theorem. Go ahead and pause the video and take a moment on the last page of your notes. Make Pascal's triangle. Remember, we talked about it in a previous lesson. But it looks like this. So keep going, so that'd be 1, 2, 3, 4 rows. Go all the way down to the 10th row. This will be something that you'll refer back to often. As we look at a plus b squared, and we get it simplified, we've got 1a squared plus 2a1b1 plus 1b squared, which can be the same as this one. So as we look at what is a pattern we see here, we look at the exponents, a squared, a to the first, and then there's nothing there at a to the 0. And then same thing with the b's, starts at 0, then 1, then 2. So the first term starts with the highest exponent. The second term will be at 0. And then this one decreases by 1. This one increases by 1 as you expand out. Remember, the main thing, or the helpful thing about Pascal's triangle is it'll help us see what the coefficients are. So that's where having it all written out for us can be helpful. So then we don't have to multiply everything out one by one. So before we start expanding, one thing we need to know is how do we use Pascal's triangle. So we've got 1, 1, 1, 1, 2, 1. We'll start there. We need to know which row is what. So looking at this, we know that this one here is the squared value. So that would be squared. This one is to the first value. This is to the 0 exponent. 3, 4, so on and so forth. So the very first row we're going to label as 0 because that would be a plus b to the 0 power would equal 1. Second one is a plus b to the first power, which is just a plus b, which they both have a coefficient of 1, so on and so forth. So if we go one more, we got 1, 5, 10, 10, 5, 1. That would be the fifth row. So we would expect a plus b to the fifth be equal to 1a to the fifth plus 5a to the fourth b plus 10a to the third b squared plus 10a squared b to the third plus 5a to the 1 b to the 4 plus b to the fifth 1b to the fifth. So ultimately how we would write that is a to the fifth plus 5a 4b, this is b to the 0 here, plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the fourth plus b to the fifth. Now remember, the two main things here is the coefficients match up with Pascal's triangle, and then looking at the exponents, this is decreasing by 1 each time, and then this is increasing by 1 each time. Those two things put together will get you the correct answer. So a plus b to the 7th, looking at your Pascal's triangle, we have a to the 7th plus 7a to the 6th b plus 21a to the 5th b squared plus 35 b to the, or a to the 4th b cubed plus 35 a to the third b squared plus 21 a squared b to the fifth. This should have been b to the fourth plus 7 a b to the sixth plus b to the seventh. All right, so go ahead and practice these. So you can pause the video, expand all of these out. So for the first one, we would expect to have 7 terms. That would be a to the sixth plus 6, a to the fifth b plus 15, a to the fourth b squared plus 20 a cubed b cubed plus 15 a squared b to the fourth plus 6 a to the fifth b plus b to the sixth. Second one, we expect there to be 5 terms. So a to the fourth plus 4a to the third b plus 6 a squared b squared plus 4 a b cubed plus b to the fourth. And the last one, there's 6 terms. So we got a 2 in there we gotta keep track of. This is to the fifth power, so it'd be 5x to the fourth 2 plus 10x to the third 2 squared plus 10x squared 2 to the third plus 5x 2 to the fourth plus 2 to the fifth. So right above we have x to the fifth plus 10x to the fourth plus 40x cubed plus 80x squared plus 80x plus 32. So another way you can figure out the coefficient is this formula here, which looks very complicated, but it's not too bad. What you'll see is this n over 1, and the n refers to whatever exponent we have. So the first one is just whatever n equals over 1. The next one, we've got 2 terms. We've got n and n minus 1. You'll notice on bottom, we've got 1 and 2. For the next one, we have n minus 1, n minus 2. So on bottom, you're just counting, you're multiplying together how many terms are on top. On top, what it is, let's say n equals 5. So this would be 5 over 1. This would be 5 times 5 minus 1 over 1 times 2, which would be 10. And here you have 5 minus 1, 5 minus 2. over 1 times 2 times 3, which would be 5 times 4 times 3 over 6. So it would be 20, 60 over 6, which would be 10 again, and so on and so forth. So you can use that fancy one if you don't want to use Pascal's triangle. You don't have Pascal's triangle with you. And then looking at this, what we'll also use this to is help us find coefficients of a term. So the first term is always just not a part of it. So really you're just counting after that, where this would be second term, third term, fourth term, so on and so forth. So when you're trying to think, like if you ask like what's the sixth term of binomial, what you're going to be doing there is taking how many you need here, which for like fourth term, there's 1, 2, 3 on top, which is 1 less than 4. For the second term, our third term, there's 1 and 2, which is 1 less than 3. So you take whatever term they're asking for, subtract 1, and that tells you how many numbers you need on top. We want to find the fourth term of x plus y to the sixth. This is where you would use that binomial theorem. So here we want the fourth term, which we were just talking about, which means on top we want n minus 1, n minus 2. Because you take the fourth term, subtract 1, you get 3. So there's 1, 2, 3 numbers there. So then on bottom, you'd have 1 times 2 times 3. So 6 is our n value, so you have 6, 6 minus 1, 6 minus 2, over 1 times 2 times 3, 6 times 5 times 4, over 1 times 2 times 3. So on top, you get 120. On bottom, you have 6, which would get you a coefficient of 20, which you check on Pascal's triangle, matches up. So that whole term then, because that's for the whole fourth term, would be 20, and then x cubed y cubed. Because the exponent of y is also going to be the same as this 4 minus 1. So for the fourth term, our y exponent would be 3, because 4 minus 1 equals 3. And then the x would be 3, because 3 plus 3 gets you 6. Each term always adds up to your exponent. So find the third term of x plus 2 or 5, so that means we're going to have n minus 1, because it's 3 for the third term, minus 1 gets us 2 numbers, over 1 times 2, so that's 5, 5 minus 1 over 2, 20 over 2 equals 10. And then for the exponents, the second one is always the same as this. So that's going to be x cubed y squared, but that y here is actually a 2. So putting it all together, we would have our coefficient of 10 times x cubed 2 squared, which would be equal to 40x cubed. So go ahead and try these practice problems. You can pause the video. Here are the solutions for each one.